Hi, welcome to Cyber Secure channel. Continuing with CKS exam essentials, as we know that curriculum outline is broadly divided into 6 domains, as flashed on the screen. In today's video, we will cover topics from second domain, which is cluster hardening, having 15% of weightage. This domain covers restricting access to Kubernetes API, role-based access control, secure usage of service account, and updating Kubernetes. Starting with the first topic, that is to restrict access to Kubernetes API. Kubernetes API can be accessed through three methods. First one is kubectl command line, second is client libraries, and the third one is REST requests. In Kubernetes, request to access the object through API follows several stages as illustrated in the diagram. First, reachability to the object is ensured through network policy, where request from a particular pod, namespace, or IP is allowed or denied through ingress or egress condition. Once the connectivity is made available, next step is authentication. Authentication process can be completed by first creating an account, which can be a service account or a user account, and then authenticating it through a client certificate, password, or a token. Next step is authorization. Kubernetes support multiple authorization modes such as attribute-based access control mode, role-based access control mode, and webhook mode. We normally use role-based access control for authorization. Next step is admission control, which can be validating where presence of an object is checked in configuration, like declaration of a namespace to a pod, or mutating, which means allocating a namespace if no namespace is defined in the configuration, or we can use the combination of both. In the end, Kubernetes auditing provides a set of records documenting the sequence of action performed in a cluster. Kubernetes cluster have two categories of users. First one is service account, which is managed by Kubernetes, and the second is normal user account that cannot be added to cluster through an API call. Normal user is considered authenticated if it presents a valid certificate signed by the cluster certificate authority. And after creation of the user, Kubernetes role-based access control is used for regulating access to resources based on the roles of the individual users within an enterprise. Now coming towards the demo, where we will implement the concept of authorization and authentication for a normal user. Just a reminder that normal user account cannot be created through API calls. Now to authenticate a normal user must have a certificate issued by Kubernetes Cluster, and then it can present the certificate of the Kubernetes API for authentication. So in the first step, we will generate PKI private key through OpenSSL command. After the generation of private key, using the same private key, we will then generate a certificate. While generating the certificate, it is important to set the common name, which is the name of the user. After defining the name of the user, we have created a certificate. Now we will create a certificate signing request by first calculating the base 64 of the newly created certificate and pasting it in the request file and generating the request through a declarative command. Now if we check the status of the certificate signing request, it is in pending state. Next step is to approve the request through kubectl command. Now in order to use this particular user, we first set credential by defining a client private key and client approved certificate. But first we have to retrieve the approved certificate for usage in the next step. With this command, we are retrieving the approved certificate of the particular user. Now, in the next step, we first set the credential by defining the client private key and the client approved certificate that we just copied. After defining the credential, now we will create a context for this particular user in Kubernetes Cluster. Now using the newly created context, we will try the command to get the pods. Clearly there is an error. Let me check the configuration again, as the configuration is telling me that I haven't defined the username. Now checking the context. I think I have found the error. That is, in the set context, I had to define the user as well, for which I have created the credentials. Now checking again. Now I am getting a forbidden pod. The command is forbidden. I am getting this particular error. This is because I haven't defined the role-based access control for this particular user. So it is not authorized to run this particular command. So in the next step, I will create a role-based access account, access controls. by defining the resources and the verbs. As you can see that I cannot run this command as well. I have to change the context to Kubernetes Cluster. And then run the same command. Now the command has been executed. Now creating the cluster role binding for the particular cluster role. And associating the user that we have just created with the cluster role. Now again checking our configuration by changing the context to the newly created context. Now if I run the command kubectl get pods, I can run this particular command. But if I want to check the deployment, I cannot run this particular command because I haven't defined the particular role for this this user in the deployment space. Now moving forward, now after configuring authentication and authorization, we move towards the admission control. We will take NodeRestriction admission control as an example, which is a validating control that limits node or pod object. A kubelet can modify and restrict kubelet to only modify their own Node API objects. It prevents kubelets from adding, removing, updating labels with the NodeRestriction.kubernetes.io/prefix. This particular label prefix is reserved for admin to isolate the workload. Further, kubelet can only add, remove, or update defined labels. Use of any other labels under kubernetes.io or k8s.io prefix by kubelets is reserved. So only particular labels can be implemented. Now moving towards the demo. Now implementing the NodeRestriction admission control through Kube API manifest. We will enable admission plugins, that is NodeRestriction. And then wait for the Kube API server to come back online. Now the Kube API server is online. Now checking the effect of the admission plugin, we will SSH to node 01 and try to label the node with the NodeRestriction label. As we can see, with this particular admission control plugin, we are now restricted to use this particular NodeRestriction label. Now checking whether we can change the label of the control plane through node 01. As you can see that it is also restricted and forbidden. So in today's video, we implemented authentication, authorization, and admission control. I hope you find this video useful. Please subscribe to remain updated with the latest videos. Thank you.